Hey friends, welcome back to the channel. And in this video, let's talk about relational databases. So if we talk about databases in general, they are one of the most crucial part of any system that you design because in the end, you need databases to store your data. And if you talk about relational databases, these are the databases which store data in rows and columns. And I think everybody knows about it. So, if we talk about history a little bit, we'll see that when the computers were invented and the data was stored on those computers were mostly related to accounting or mostly it was invented or prepared to serve the financial industry. So at that time, if you look at the MS Excel or Google Sheets right now, so this is how the ledgers at that time used to look like for accounting purposes and other financial needs. So that is how relational databases come into existence and how the data was stored in those, which is representing them in rows and columns. So because of these properties and this application, uh, the relational databases had key properties like these should be consistent, they should be durable, they should have high integrity, they should there should be constraints available, and all the data should be in one place. And because of all these reasons, we have something called as the transactions. So transactions are nothing but they are just the logical unit of work. And these transactions helps us build systems and application logic. So consider transaction as a group of different kind of statements like update, insert, delete, all these kind of things. And the and these transactions are governed by the ACID properties. Now, this ACID properties may seem fancy, but relational databases are popular because of these properties. And ACID stands for atomicity, consistency, isolation, and durability. Now, let's talk about each of them one by one. So, first, let's talk about atomicity. Now, this is the property that states that in a single transaction, either all of these statements will be executed or none of them will be executed. So here I have given an example and I have started my transaction and I have two statements. One is for insert and one is for update. And then I'm going to commit this transactions. Now, what might happen is when I've executed this statement, which is insert, and between here, my application crash, my system crash, and this update is not executed. Now, relational databases being atomic guarantees you that either all of these statements in the transactions will be committed or none of them will be committed. So if the system fails and this transaction is not committed yet, we won't see any of these statements updated in a database. Now let's talk about consistency. And consistency simply means that the data that we have will never go incorrect. And we have necessary tools for that. So, for example, we have cascades or triggers. And cascades being if I want to delete a specific row, I would need to delete all the data associated with it. So consider this. For example, I have a foreign key checks that do not allow you to delete parent if any of its child exists. So this basically means the same. If there is some data associated with a row, we won't be able to delete it. Or we also have triggers. Now, this is quite similar to what a transaction does. So trigger basically means when something happens, it should trigger some other operations. And for that, we can use triggers, but mostly transactions are used because transactions also give you atomicity. Third is the durability. So whenever there's a transaction that happens, and the one thing that the database confirms is that the data is durable. The data is not going to like vanish. So if the system crashes or anything happens to your database or a system, the data will be stored in a disk. and it is guaranteed that you would never lose your data. Like the data is not going to just vanish out of nowhere. Now talking about the fourth property, which is isolation. So we have different kind of isolation levels, and we'll be talking about in the next section all of them. And what isolation means is, let's say we have multiple transactions going on parallelly. So let's say we have a session 1, and here we have a session 2. Now these isolation levels will determine how much changes of one transaction are visible to others. So let's say we have this transaction and there's something changed in here. So if this is going to be visible there or not, or should these changes be visible to other transactions before the transaction is even committed. So this is on the higher level what isolation is. And if we talk about different levels of isolation, let's talk about them one by one. So we'll be talking about the four standard SQL isolations levels that are possible. And first is the repeatable reads. So we'll go directly to our example, and let's say we have two sessions that we have opened side by side, and this is like the MySQL for just for example. And here I have started a transaction in both of our session. Currently, the table that we have for our database is something like this. We have a user ID and a name. Now, in transaction 1, I have updated the table. And now the updated name is A underscore T1. Now, and if I see in the session 2, the table, we will see the previous name, which is A. But now when I have committed in the transaction the but when I have committed in the session 1, the table is something like this. And on the same time, in a session 2, if we show the table, keep in mind that the session 1 has already committed the changes. It is still showing the previous name. But the moment I commit both, in the both sessions, I will receive the updated name in my table. Now, let's talk about the second type of isolation level, which is read committed. And what does this means? There is that read within the same transactions always reads the fresh value. Now let's just uh, come to an example. Again, we have two sessions with us, and we have the table as this one. Now, what we have done is we have updated the name in our session 2, which is underscore a a underscore t2, and we have committed this transaction. And the moment we have committed this transactions, we are able to see the updated name in our other session, which is different from the previous isolation levels. In the previous isolation level, if we have to see this updated name, we have to commit this transaction as well. But in this case, we need not to commit this transaction. And if this transaction is committed, we can see the updated value in our table. And this simply means that we are always reading the committed value. Now, the third type of isolation level is the read uncommitted. Now, and thus what happens is, even if any of the transaction is not committed, the other transaction can see its value. Quickly, let's understand it with the help of an example. Now, in this case, we have this table with us with a user ID and name. Now we have two transactions running in both session 1 and session 2 respectively. And in this case, what we'll do is we have this table and we'll update the name to a underscore t2. And now when this happen, and if we do the show table in our session 1, it will show us the uncommitted value. And this can be a bit problematic, because what can happen is, if even if we are doing some kind of, let's say, query or some kind of processing on this table, we'll be using this name a underscore t2. But what can happen is in the session 2, because of some reason there can be some kind of rollback, and in this case we'll go back to our name a. But here we'll be doing all the processing with the a underscore t2, which is going to cause the dirty read problem with us. And because this is reading the uncommitted values, there can always be chance of processing done on some unlikely data. And in the end, let's talk about the fourth type of isolation level, which is serializable. And what it means is that every read that you're doing is a locking read, which is whenever you are doing a certain transaction, and when it is reading the data, other transaction has to wait. So consider this MySQL example, and I have some some table with me, and I have been querying on that table, and if I'll do the show table on my second transaction, it is going to wait unless I commit in my first transaction. So the moment I commit this particular transaction, this is going to be executed and I will be able to see my data. So what it signifies is every read is a locking read. So this is going to lock all the other transaction to read this particular data until I commit this transaction. After that only we are able to see the table in the second session. Until then it is going to wait. So these were the different kind of isolations level, and this is what I wanted to discuss about the relational databases, about the history, what are the benefits of using them, and what are the things that you can achieve while implementing it in your system design. And in the next video, we'll be talking about non-relational databases as well in brief. So that's it for today. See you in the next one.